Hi, I'm Anne Bachmann-Volkmann, and I'm looking into iceberg studies using artificial intelligence and mapping these icebergs, their outline and their area in satellite images. So this new neural network is 10,000 times faster than humans can do this task, and it maps the iceberg extent and the iceberg outline in less than a hundredth of a second, whereas humans would need several minutes to generate each of these outlines. So with this new neural network, it's possible to get out the iceberg surface area. And when we apply it to several images of the same iceberg, we can see how the iceberg area shrinks and how this iceberg is breaking apart. If we also want to see how the iceberg is melting from underneath, we need a different satellite technique to measure the thickness, but this can actually already be automated to a large extent. So what was really the bottleneck so far is that we needed manual outlines for the area change. And now everything could be combined, and we could also calculate the whole freshwater flux from icebergs automatically.
The atmosphere where a lot of that carbon is being absorbed and deposited. So it's important that much more far-reaching implications for the climate than just in the Arctic.
Yeah.
So they can do the world ocean. This is the temperature you say here, and also the sea ice, which is kind of the area of interest. The point about icebergs is that they are generated at ice sheets, then they move around with the ocean circulation, and they encounter warmer water as they go south or north in the Antarctic. As they melt, they deliver the fresh water into the ocean. That's a freshwater flux into the ocean. And that flux then can impact the ocean circulation potentially quite strongly as the icebergs, the number of icebergs becomes larger. And that's kind of one of the main impacts of the icebergs on the ocean.
I think it would be the logical next step to really automate the whole chain that's needed for this, downloading the images, applying the artificial intelligence to get the iceberg outline, and then combining it also with thickness measurements to get the freshwater flux of icebergs along their trajectory completely automatically. I think that would be the dream. But I think you can always improve the algorithm and retrain it with more sample images of a wider variety of icebergs, also more different iceberg sizes and so on. And then I think the algorithm could get even more accurate. But I think the study has already proven that it's a very powerful and very useful tool for this. Yeah.
Because the satellite data allows us to validate the models. the ocean surface temperature as time goes on. AI and machine learning is, in some ways, is perfectly suited to tracking, to recognizing features very quickly and very accurately. So I think this is a great technique to use. It's important to track icebergs in real time. For a lot of that's for operational reasons, so it affects shipping, it can be a danger to shipping. There are other hazards, such as the icebergs can often scrape the bottom actually in coastal regions, and our submarine cables, our communication lines are often dependent on subsea cables. So that's two good reasons why we want to track icebergs in real time. And the potential results of this are quite, potentially quite severe. So one of the big concerns about the ice sheets is that there could be some runaway effects. So as carving of ice sheets becomes increases in frequency, then that in itself could create an acceleration of the ice sheet melt and further carving. So you could get a positive feedback where the ice sheets rapidly lose ice, and there could even be a point of no return where even if we do our best to reduce emissions and reduce the warming, the ice sheet's on a trajectory to disappear on some timescale. So that's a real worry.